The Green Roof started as an urban horticulture project, and currently we have one amazing project by alumni Austin Little, who is researching an interesting breed of peppers.
Okay, so my name is Austin Little, and I am now a horticulture educator with the University of Illinois Extension. And so I work in Jackson County and the surrounding counties here in our unit. And I've been doing that since 2019, since I pretty much graduated from SIU. So I have been involved with the Green Roof up here since 2013. A couple years after I started my undergraduate degree here at the College of Ag at SIU. So in one way or another, I've been working up here on the roof for about 8 years. And in 2013, as an undergrad still, that's when I really started to work on kind of the research side of the Green Roof here. I helped install these plots here and the plots along the south edge there. And in the following year, when I started my master's degree in horticulture, and that's when I started to actually do some research up here. So in one way or the other, I've been doing research up here even up until now. We're still doing research up here. And the work that I've done has been focused on our medium fertility. So the fertility of the soilless medium that we have up here on the Green Roof. And the master's degree research that I did was focusing on urban agriculture. So how can we utilize roof space in urban areas to increase local, fresh, and sustainable food sources within urban areas where we have kind of some issues with food access, food deserts, these kind of things. But there are also these other environmental and economic benefits of green roofs that are really important. Number one being stormwater retention, added effect of impact on the urban heat island effect, and reduced heating and energy costs, increased green space, increased ecological space, so improving biodiversity as well in urban areas. And so through the course of the history of the Green Roof up here, which was installed with the help of the SIUC Green Fund, that was a major benefit to getting this established, and to other green infrastructures that we have here at SIU, which I still use in my career today, which we're really lucky to have here. So that was a major benefit to getting this installed up here in 2010. And we also, I wrote a grant for the tiles that we're standing on here too, through the Green Fund. And the Green Fund is really influential in supporting a lot of these programs, along with Nelson and the engineering team that are working on some really amazing projects to kind of take the Green Roof into the future here. So they're working on a wind turbine for a weather station, and what I'm really even more excited about, well, that's exciting, but we're also talking about doing an automated smart watering system. So that's really exciting as well, and the Green Fund is going to help support that as well. So without that Green Fund, I'm not sure if I would have been able to do the research that I've done up here, and in a lot of ways it's helped me to be able to get to where I am now. So I really can't say enough about that. So what we're working on right now, I started this research project here last year. So this is another kind of fertility project that we're looking at here. And this one is a little different than the first one. The first one we did for my master's degree was looking at a range of different fertilizers. So we looked at 6 different fertilizers. Some were organic, some were more conventional. We grew banana peppers and melons along the back there. So that was a really interesting study, and we got some really useful info out of that. It turns out that in this kind of situation where we're in an extensive green roof, which is pretty shallow compared to a deeper, intensive green roof, in this kind of system, slow release fertilizers that are quick to absorb into the medium work the best. So slow release, but quick to be able to be taken up by roots. Now what we're looking at here in this study is looking at how quick organic compost breaks down in this soilless medium here. And so we're looking at a range of amendments, different rates. So we're going from 0, which is our control, up to 20 pounds. And what we're looking at is how fast that breaks down over the growing season. And we're doing this 2 times, so it's both repeated in time and in space. So we're doing it twice in 2 years, and then in 2 subplots here for each treatment. And so what we're going to see at the end is what's the difference between the weight of the medium plus the added compost compared to the beginning of the season, and then compare that at the end. And so hopefully what we're going to see is how quick that compost breaks down and what rates actually are going to be completely broken down throughout the growing season, so that we can avoid over fertilizing or over amending our medium, so we don't run into overloading our weight load capacities for the structural weight loads, and so that we're not adding extra unneeded runoff and nutrients into the stormwater, because that would be mitigating a big benefit of green roofs, which is stormwater reduction and recycling and cleaning stormwater, so that it's reducing the burden on stormwater systems. So that is the research here. And now we're in our 2nd year. I think we've got maybe 1 more harvest on here, and the peppers are doing pretty good. Nelson had asked me what the difference is between the green and red peppers here, and they're the same pepper, they're cayenne. So the great thing about cayenne is that it's really easy to tell when they're ready to harvest because they turn red. So that's a quick indicator to know when to pick them. And the data that we're taking, so we're taking that difference in weight over the years, so temporal and spatial data there. But for the peppers, we're also taking weight, total weight of each treatment in each plot. We're taking the count, so the actual count of fruit that we get off of there. We're taking a vigor rating, which is kind of an objective, just overall health of the plant and performance on each one. So that's a kind of a qualitative scale, a qualitative data. And then we also use a SPAD meter, which is a little device that you take samples from you just kind of clamp it onto a leaf, and it shoots a laser through there and tells you how much active chlorophyll is in there by how much green light is reflected, which is a really neat little device. So that gives us a reading on how metabolically active these plants are. So that gives us an idea of how effective the treatments are for how well the plants are performing. So that will all be tied into the breakdown of the different rates of compost in here. And so I'm really excited to kind of see some preliminary data. I think we're pretty close to be able to take data on this after we do another harvest and get our final weights. We can start to plug those numbers in and actually get some useful information out of there. So that is this research here. Other research in the past, other graduate students have looked at growing tomatoes on the green roof, lettuce, herbs, and some other things I believe as well. So there's been over the years a range of different research going on up here. But right now we've got some plots here that have more kind of grasses and native plants in this section here and in this section. And this last summer over here, we tried some edible landscaping where we looked at some what are called All-American winners. They're kind of varieties that have been tested in trials throughout the country. So we grew some tomatoes, peppers. You can still see some of the zinnias in there, and that was a lot of fun. So that's kind of what we've been up to up here on the green roof. And so kind of the future we had talked about with the engineering projects that Nelson and the team are involved in. Again, the wind turbine for the weather station, the smart grid watering system, which that sounds amazing to me. So I'm really excited to see where it goes and kind of see what we can accomplish up here in the future.